Hi everyone, today I'm reviewing Charles Schmidt's 2017 article, Don't Drink the Water, which looks at perfluorochemicals, often called forever chemicals, and how they move through the environment and into our drinking water. I'll explain what these chemicals are, why they matter for the critical zone, and what the article does well and could improve upon. PFCs are man-made chemicals used for their non-stick and waterproof properties in things like Teflon, Scotchgard, and grease-resistant food packaging. What makes them useful is also what makes them a problem. The carbon-fluorine bond is so strong that these chemicals do not break down in nature. They persist in soil, water, and even our own bloodstreams. Nearly everyone in industrialized countries has measurable levels of PFCs in them. On this slide, I included a short animation of the chemical structure of PFCs to visually show how the strong carbon-fluorine bonds make these compounds so persistent. This article is highly relevant to critical zone science because it shows how pollution moves through the entire layer where life interacts with soil and water. The chemicals start at the surface, like firefighting foam, and move downward into the soil, then into groundwater, and eventually into drinking water and living organisms. It demonstrates how interconnected the critical zone is and how quickly human activity can introduce long-lasting pollutants into natural systems. This USGS diagram helps illustrate the major PFCs transport pathways through soil, groundwater, and ecosystems within the critical zone. One example Schmidt focuses on is the Peace Trade Port in New Hampshire, where the U.S. Air Force repeatedly used firefighting foam containing PFCs for decades. These chemicals seeped into soil, infiltrated groundwater, and contaminated the local drinking water at levels 35 times higher than the EPA's advisory limit. Residents found out only after years of exposure, which adds a human and emotional dimension to this issue. Similar contamination hotspots have been found around the country, especially near military bases and chemical manufacturing plants. I've included this map directly from the article showing the PFC hotspots across the United States. One strength of Schmidt's article is that it balances scientific research with personal stories. He explains the chemistry without overwhelming readers, and he highlights the emotional side, families discovering contamination in their water. By using credible research to support his claims, he effectively makes the chemistry accessible to a broader audience. He also highlights community frustration and public health concerns in relation to slow government action, which keeps the issue relatable and is important for understanding the bigger picture. I added this ATSDR exposure pathway schematic to show just how PFCs move from environmental sources into human exposure routes, which supports what the article explains very well. One limitation is that Schmidt mainly focuses on U.S. examples, even though PFC contamination is a global issue. He also doesn't explain how scientists actually detect or track PFCs in soil or water. For example, tracer studies, groundwater sampling, soil cores, or plume mapping. And he talks mostly about human health, but PFCs also affect plants, wildlife, and entire ecosystems. While the human health angle is important, a stronger discussion of ecosystem impacts would better connect it to critical zone science. Lastly, he could have included comparisons with other pollutants to help readers understand how widespread persistent chemicals really are. This global map highlights PFC contamination hotspots worldwide, emphasizing the international context that the article could have discussed more deeply. From this review, I learned just how persistent and mobile PFCs are. They don't go away for decades, and they travel through soil and water much more easily than I realized. I also learned that exposure is almost universal, which makes it even more important for policymakers to regulate these chemicals. Personally, it's made me more aware of everyday products like nonstick cookware or stain-resistant textiles that may contain PFCs and how policy hasn't caught up with the science yet. The infographic on the left clearly shows the different ways PFCs enter drinking water as well as the normal everyday products that they're found in. To wrap up, Schmidt's article is a clear and engaging look at how PFCs contaminate the critical zone and affect human health. While he could have gone deeper into scientific methods and global perspectives, the article succeeds in raising awareness about a serious and ongoing environmental issue. This topic continues to evolve as new research emerges and communities push for stronger regulations. I also included this diagram of the PFA cycle to show that contamination continues across many systems, underscoring why ongoing critical zone monitoring is essential.